This is Algebra 1, Term 6, Lesson 4, Outliers. Today we will learn how to determine if a data point is an outlier in a Desmos activity, and then we'll do some analysis of our distance from school, and we'll finish by creating two GeoGebra box plots. So let's start in Desmos. This activity, Outliers, has a total of 11 screens. There is a bit of calculations involved again, so these do take a little bit of time. So even though they're short, kids tend to spend a while in these. My students sometimes would open up a second screen to use Desmos instead of using the one inside the activity, and that is totally up to you. But for a lot of these students, they can do things quicker and see them better in the bigger calculator, so that is something you might want to suggest while they're working through these activities. Okay, so the first thing they're going to do is look at this graph. These two graphs represent the same set of data. One is a bar graph and one is a box plot. And I want them to list three things. And the first thing here is something that must be true based on this data, something that might be true, but you can't know for sure just by looking at these graphs. And then the third thing, something is absolutely false about the data. But anyway, there's a long list. I've given you a sample, but just know don't limit it to that sample. There's more that kids could say. Here we have a histogram, and there is an outlier. So you're being told there's an outlier, and the outlier is far from the others. Sketch and make a prediction as to the location and the amount, the number for that outlier. On screen 3, we are finally learning how to determine what an outlier is with the actual calculation. So they're going to do this for the first time, and this talks them through it step by step. They do need to know how to make these calculations. In reality, though, if they're tested on this and they're using their Desmos calculator, they will, if they have access to their box plot, they can just turn on or turn off their outliers to see if a point is an outlier or not. I do know some state tests block that functionality, so if students need to know this for their assessment, they will have to do what they're doing on this screen. So the first thing they'll do is estimate their IQR by getting the width of this box. So they'll have to estimate Q1, estimate Q3, and subtract those numbers and put that here. They will multiply that value, whatever that IQR is, by 1.5, and they will put that result for number 2. They need to know the approximate value for Q3, which they already used that to calculate the IQR, so whatever they chose, they need to put that here. They will add the results 2 and 3 and put that here. Now they're going to put that answer on this graph. This is called the upper fence. This is telling you any number going past that fence is too big and it will be considered an outlier. Anything inside the fence is fine. So they'll add that to the graph, and then they'll answer this question: is this maximum an outlier? Is it outside the fence? But you'll see the upper fence is actually represented by this little dashed whisker. This right little mark here is where that upper fence should be in their graph, and you'll notice that the 45, or I think it's 44, is outside that fence, so it's definitely an outlier. The minimum is also an outlier because it's to the left of the lower fence, which is this left side of your box. Subtract 1.5 times the IQR, and that's going to land you right around 2.5. So here I want them to list two more potential data points that could be outliers, so you can just pick any numbers in between 42.5 and 45, or you could pick any number between 0 and 2.5. I gave you a few examples in your sample responses. They could choose. All right, now for the next one, this is important that you have them follow these directions because they're going to create their own list in the calculator, and they can actually cut and paste to do this. This is one really cool thing about the Desmos calculator. Unlike the handhelds where they have to manually type in or use cables, or they've got other ways to do it, but there's no easy way to do it. The easy thing to do here, though, is just highlight using your mouse or your trackpad, whatever they've got, and type Control-C, and it will copy that data. They're going to go to the next screen, and they're going to paste it. Down here in this box, all they have to do is say, do you notice any numbers that might be an outlier in this data set? So they can look at the numbers, and hopefully they notice one of them is kind of big compared to the others. All right, click over here. Now you can't just paste it. You have to start by typing a list, and it tells them up here what to do. Create a new list in row 1 by typing H, so type H, type equals, and then a square bracket. It's right next to the P on the keyboard. So if they're having trouble finding that little bracket, it's above the enter key. It's to the right of the P. It's somewhere in there. Now when they type Control V will paste that list. So we just typed in 34 elements that fast. So copying and pasting is wonderful. It not only works for this, but they can copy out of Excel spreadsheets. They can copy whole columns, headers included. It knows not to put the header in there. I don't know how it does that, but it'll take it and put it in there. You can put them in lists and tables, and copying and pasting is wonderful in Desmos. All right, now that we've done that, we're supposed to create the list, then the box plot. So remember, they just type box plot, and then they're going to type in the variable H, and there's the box plot. You can hit the little plus sign here. This is called Zoom Fit, and it zooms in a little bit. Now we're also supposed to also do the 5-number summary, so they're going to do STATS and type in H. And they're supposed to find the mean. So let's do the mean. MEAN H. So we already have the median in our 5-number summary. All right, so we've got everything that we need. Now you'll notice that it excluded that outlier. Isn't that interesting? So it kind of automatically does that. So they now see that it's an outlier with their box plot if they didn't have it before. Now when you take out the outlier, like exclude outliers, it will go ahead and put the whisker all the way out. But see, this is kind of a way to check your answer, is by actually graphing it and then say exclude outliers. It'll show you if something's an outlier. It will automatically do all those calculations for you. Now, on the next screen, they're going to calculate all of these. They have to toggle back and forth, but they're basically going to put their 5-number summary that they got here on their screen number 6. They're going to put that into this table, so they'll need their Q1, their median, their Q3. They got to calculate their IQR. They really should do it in the calculator. You can calculate in the box itself, but it cuts off the digits, and the directions over here say round all values to 4 decimal places, so you kind of need to see all that in the table. So go ahead and do it. What happens as they are typing these in is these check marks will appear, and they will show whether they're right or not, so they can just keep working on it till they get all their check marks and get all that correct. Now the next thing it says, should the per capita health spending for the U.S. be considered an outlier? And so what they're going to do is actually do the calculations. They will take the Q3, which should be here in this table, and then they will take 1.5 times the IQR. They will get their own IQR this time, subtract Q3 minus Q1, and multiply that answer by 1.5. Add that to Q3, and is the maximum higher? So in the box, when they say yes, it's going to tell them use the definition of an outlier. Okay, so they've got to use that in their explanation, so they're kind of showing that calculation. The sample responses shows what that should look like. All right, this one says, we know we shouldn't just remove outliers without considering their cause, but they do have a big impact on the statistics, particularly on the mean and the standard deviation. Now, I didn't have standard deviation in this, but I did add an extra screen with that so that we could look at that too. Now this is saying go back to screen 6 and remove the value for the United States. You can do that, and I probably should change these instructions, but another way you could do this is you could go here and edit your list, and you can copy the list, and then you can rename the list. So I'm going to come back over here and rename it, because you can't have 2 lists with the same name. Let's say this one is, I'll put an N. All right, I'm going to change this name to N, And see, it's still a 34 list. Now I've got to go through, and I'm going to pull this out so I can see better. And I'm going to go back to the very end of my data, and I'm going to eliminate the United States, which was actually the very last data point. Let's get rid of that. And now I have 33 elements. Now you can change these to n's if you want, or you can create new ones. If you want to compare them, it's sometimes a good idea to create new ones. So I'm going to change that to an n. I'm going to change that to an n. I'll change that to an n. All right, here's my box plot. Let's move this back over. I think I'll hit zoom fit. And look at that. That's some pretty symmetric looking data. It's not all spread out. It says exclude outliers. There are no outliers now. So here's your new min, and they can check all their answers. Their mean, and then they can talk about them. So what I was saying is you can eliminate the number from the list and do it, or they can create a new list and eliminate it. That way you're not losing your original data if you need to go back and use it. I guess it's not that hard to put it back in there, but I usually do it that way myself. So on screen 8, it does say what's going to happen, which measure of center changed the most when we took that outlier out. Did the mean change a lot, or did the median change a lot? I think they both change some, and sometimes the median doesn't change at all, but in this case I think the median does change. I think everything changes a little bit, but notice the main difference here in the mean and the median, and I do have some teacher moves and sample responses there for you to read. All right, and I didn't want to leave standard deviation out, so I've added this screen. I've given them H, that's the 34 element list, that was the original, and I've given them N, now this is the list with the US removed. So the standard deviation with and without the United States data is shown. So the question is, how did taking out the United States change the standard deviation? And then what dollar amount does that represent? Because this was money. They were talking about money that was spent on health care per person. Which measure of spread was most impacted by removing the US data? Was it the IQR, or was it the standard deviation? So they're going to have to go back and look at the original IQR and the one that changed, and then look at these two and see which one changed the most. So the question on screen 10 is the minimum 1.0803. That's not shown here, but that was the min in the data. Is that also an outlier? So they're going to use the calculation Q1, which is in this table, minus 1.5 times the IQR, and they can recalculate their IQR if they don't have that. So we know the outliers will go outside the fence. In other words, be lower than the lower fence. And so we're going to show if that's true or not, and then answer this question. And then finally, we're doing something completely different, and this is kind of like a little assessment to see if they're learning it, if they know it. Here's your group of students. Here are your results. Is there a point that's an outlier? So they will need to explain by using 1.5 times the IQR in their explanation. So be sure that's included. For the next activity, we'll go back to our slides. So this activity is going to use Google Maps, and students are going to determine their distance from school. Now I'm going to preface this, be careful with this activity, because you do sometimes have students who are homeless and they do not have a home. And another thing is you don't want to reveal students' personal data to the whole class. So they should not have their street address put up in front of other students. So sometimes, I told you in the last lesson, I sometimes put their data up and other kids can look at it. Definitely not for this assignment. I don't want other kids looking at student data. So kind of guard that and protect your kids, particularly kids that may be homeless. I had a girl that lived in a car in one of my classes. I knew about it, thank goodness, and I kind of, before we do a lesson like this one, I would go to her and say, okay, just put in the Dollar General over here on Gaucher Road. Don't put in, don't worry about that. If you don't want people to know where you live and you want to lie and use some other person's address, totally okay with that. So anytime there's any kind of sensitive situation going on, just be aware this could be potentially a problem. I'd say for the vast majority of students, this is no big deal, but just be aware. This is kind of one of those risky assignments. It's so much fun that I do it and I just find a way to help those kids not be uncomfortable. All right, so here's what you'll do. You'll go to Maps. They will click on Directions. They will choose a starting point. They can choose any starting point they want. It can be a lie for those kids that we don't want to reveal where they're starting. They need to type in the school for the destination. They will get their time and distance from the graph. So let me show you what that looks like. So this would have been my starting point when I lived in Gaucher. I actually lived up here on Cotita Drive for a short while. I didn't live there long, not even a year, but this would have been my drive to school. But see, you know what? This was a terrible way to drive to school because they had a lot of construction down here. So I would actually have used this one. All right, and they would paste that on their slides. Now they're supposed to record their time and distance in the class data. So you have different ways you can do that. You could just have a giant board at the front of the room and people just record their data in the big table and people copy it manually into a list or into a Desmos graph. For one class, that's probably sufficient. In fact, it might be more fun to do that way. But what I used to do is a Google form, and I would send the form out and they would type in their data into the form. So it would have two questions. The first would be, how long does it take you to drive to school or come to school in minutes? They'd put their number. How far was the trip to school in miles? And they would put their number. So however you want to do it. Forms make things go quickly, but if it's not a matter of quickly, you just rather have them manually do it, that's absolutely fine. All right, when they get to the next one, now we're going back here and we're going into two variable data for this particular activity. They will create a table in Desmos. So click the plus sign, add a table. In list one, in the first column, X1, they will enter their times. And in their second column, they will enter their distances. And they definitely want to keep them matched, like time with distance. So we don't want to start sorting our lists at all to do this. And then generate a linear regression equation. That's y1 tilde mx1 plus b. They've done these all year long, so this should be a review task for all students. They will click zoom fit and add some labels to the graph. So they need to click the wrench. And they need to put time in minutes, distance in miles, and then they need to answer this question because this is the bulk of this task right here. What does this graph and correlation coefficient reveal about the relationship between the distance and the time, and is there a strong or a weak association? So they should have a correlation coefficient generated that shows this, and they should have some text here describing what's going on with this data. In general, there's usually a fairly strong association, but it depends on your school district. So I usually added my own data, or I added extra points to make it interesting, and I would put my personal data in there too because I never lived, within the school district. Usually I lived a district over or, significantly farther than the average student. So my data could be like an outlier. All right, now that we've looked at a distance time graph, they're going to go back and look at this again, but this time they're only looking at distance data, and they're going to create a list in Desmos with just the distance data. So not the table, but a list. They will create a dot plot and a box plot, use the offset in their box plot so they can make their box plot rise up above their dot plot, and then calculate all of their statistics, the mean, the 5-number summary. They need to do the standard deviation and then calculate their IQR and then use the formula that we learned today to determine if any of those data points are outliers. And then write a summary of findings about distances the students travel to school. So this is our last activity for this lesson, GeoGebra box plots. They will go to GeoGebra and move the data around to make the graph symmetric, and then they're going to create an outlier, prove that it is an outlier by calculation. They have to do this twice, one with a lower fence and one with an upper fence. So let's take a look at GeoGebra. Now when they get in here, this is what they're going to see, a bunch of points. I don't even know what the A and the B mean, but I just decided to make those my min and max. So get all your data closer together and symmetric. We've done this before where they had to create outliers. So the first thing you want to do is try to get your data all grouped close together. Evenly spaced would be nice. and then click here. Now, one way they can know it's symmetric is by choosing or making that mean and median the same. And so these are pretty close. Let's see if we can move this data in a little bit more. Look at that. That's almost perfect. It says they're both 17, so that's good. Now, once they get it that way, they're going to take a point and they're going to move it way outside the data set. Let's move it way over here. I don't know, or one of them had to go this way. And then they're going to calculate to see if that is actually an outlier. Now, let me caution you, if you select outliers, you can click on this point and it will make it an outlier. But guess what? It'll make anything an outlier. It'll put them in the middle of here. So this is not helpful. Don't let them, tell them, don't let that influence you. It'll mark whatever you tell it to. But you may not want to select your outliers. You may want to just do the calculations. And so what they would do is they need to get 3/4 of this box. So that would be, let's see, there's half of it. So that would be 1/4. So it needs to be more than that distance away from A. I'm thinking I need to move A in a little bit. So that might be an outlier. But I can calculate to make sure that it's an outlier by doing the calculation. And then I will take a picture and put it on the slide. If it fails, they need to choose something else for the lower one. They need to make sure it does work. And then they'll do it again, put a point way above the data, higher than the data, make sure it goes outside that upper fence, and then prove that it is an outlier by calculation. They will paste pictures of their number line with all their stuff selected at the top so you can see that and any work that they've done, including this calculation. And that concludes our lesson on outliers. The next class is their one and only test for term 6. My suggestion, if you're going to do test corrections, right now would be a great time to do them, because this test is cumulative and it's the last regular test that's cumulative, and they can go back over some of the things they did on their last test to prepare for this one. We have 3 lessons after our test, and then our final exam for the course, which is also cumulative. If y'all have any questions, if you need anything specific, please let me know. I'm still working on developing content. I'd like to take care of what you need. Y'all have a great day.